Okay. So regression analysis. So as you guys know, regression is when you're trying to fit your data to some sort of model. That's what regression stands for. And you're trying to regress towards the mean. Like you're trying to figure out what is kind of like the best fit for a certain set of data. You guys know best fit lines from bio, maybe, or chemistry. Like you have a bunch of data points, a scatter plot, and you try and find a line to fit the data. Maybe a classic example would be if I were to survey everybody, hey, give me your height in inches, give me your weight in pounds, and we kind of like plot it all. Of course, the shortest person probably weighs the least, the tallest person probably weighs the most. Then you see a correlation, right? But we're not going to do linear regression because linear regression is too basic, too simple. We're going to do other types like exponential regression, logistic regression, I think. Oh, I'll take a call, thanks. Um, um, Logarithmic regression as well. So we're gonna do 3 types of regression techniques. Again, I'll do it in the calculator just to see how it's done in the calculator, but you're gonna kind of go crazy when you have to do this like over and over again in the calculator because it's kind of a pain to keep punching these numbers in. Desmos actually has a really cool feature. Yeah, it's the last 2 pages of the notes.
Oh, okay.
Yeah, you should have it already.
Yeah.
And Desmos again, for those who are taking the SAT next month, there's actually a way you could do regression in Desmos, which actually will be hugely helpful when you're trying to do certain problems, especially in the second module if you do well in the first module. Okay, so let's talk about what's happening here. The other thing too, we have to define variables as being independent and dependent. So good example would be, actually, you guys are talking about sleep, right? This is good. What if I surveyed you guys, and of course, hopefully you guys are honest, like how much sleep you get during the week and what your GPA is. Okay. I mean, granted, I think everyone's GPA is really high. So but in general, you would expect that those who probably sleep more might do better in school, right? So sleep will be my independent variable, right? Because we can choose, right, how much we want to sleep. You can sleep maybe 4 hours, 5 hours, set your alarm, whatever, right? The dependent variable would be GPA as the response. How does the GPA respond to your sleep, right? So that's depending on the sleep, right? If you sleep more, you might get a better GPA. If you sleep less, you might get a lower GPA. So that's the outcome. So that's what we're going to be looking at. We're looking at independent versus dependent. Independence X, dependence Y. So that's kind of how we're going to look at it. Another example could be years of education and your income, right? If you include like undergraduate and graduate school or getting a PhD or doctorate, you'd imagine those that have more years of education would have a higher income, right? So you can see a correlation there. The income would be the response or dependent variable. The years of education, because you choose how many years you want to go to school, would be independent or be X or the predictor variable. So in this case, for exponential regression, we're looking at time and closing price of a stock. The stock we're looking at is Harley Davidson, so motorcycle company, obviously. And before we get too deep into it, it's kind of a fun historical problem to do as well, right? Because if you look at the economy or the stock market and what happened in U.S. history, there seems to be a correlation as well, right? Before we get too deep into it, take a look at like the stock price. It's kind of low for a while, right? And then something happened in the mid-90s. What happened in the mid-90s? Economically in our country, what the stock market actually did really well. Did in the mid-90s.
Couldn't have been more wrong.
Right. So a lot of these beautiful homes you see here, a lot of these people bought their homes in the 90s for like maybe $1 million or $2 million. Now they're worth like $10 to $20 million, right? A lot of these people are influential in Silicon Valley, right? So the Silicon Valley, there's the dot-com boom. You might hear about that. A lot of people did really well. And then around 2000, 2001, it hit a peak, and then the stock price came down. What do you think happened around 2001, 2002? What do you think historically happened? What did you say? What happened on September 11th, 2001? 9/11. And the country went at war, right? And so so the stock market had a correction around that time as well. So usually when you have like disasters like that, that can impact the economy. So it's just kind of neat to kind of take a look at it a little bit. Anyhow, I know I digress. So let's actually do this in the calculator. So I'm gonna pull up the calculator. Here's how you do it. We're gonna go to stat. And the first thing you see is that, and I know this is kind of hard to read for those sitting in the back. but hit stat, and the first thing you should see is edit. If you hit enter, you see a table like this. You should see, hopefully it's blank. If it's not blank, I'll tell you how to clear it. You see L1, L2, L3, L4, whatever, right? Now, if I had some random numbers here, let's have some random numbers here, right? Okay, I want to get rid of that. That's bugging me. If you want to get rid of it, use the up arrow key, have L1 selected, just hit clear, and hit the down key. It wipes away all the entries in that column. Okay. So if you need to wipe things away, you can also reset your calculator too if you want. You can, but you don't want to lose your program. So again, if you see any data already in the table, and how do you get there again? Just hit stat, and then edit. Oh, hit the up key and hit clear. And hit down afterwards. Okay. So what we're gonna do, and this is the part that's a pain in the ass, we have to type in all the data points in this table. Obviously, there's 17 data points for each column. So we'll let L1 be X, which is time in years since 1980, actually since 1986, because X equals 1 corresponds to 1987. And then the closing process will be off to the right. So I'll do 1, 2, 3, 4, 5, 6, 7, 8, 9. It's easier for me because I have a keyboard. It's gonna be a little harder for you guys. So I'll be patient. Notice I made a mistake already. 14, 15, 16, 17. Oh, 17. Okay. 0.392. 0.652. By the way, you don't do this in real life. You're usually given usually a CSV file that has a bunch of data that you need to work with. 2.6998, I think. 2.6998. 4.5381. 5.3379. 6.8. Ah, Jesus Christ. Damn it. 6.8032. 7.0328. 7.0328. 11.5585. 13.4799. 23.5424. 31.9342. 39.7277. 54.31. 46.2. Sorry, guys. 47.53. Okay. And just be sure, I mean, if you might have goofed, if you typed this in wrong, just be careful.
Mine rounds to 300.
Oh, that's weird. Oh, you know what it is? Hit mode. And do you see, is float selected or is
Yeah, float.
oh, really? I wonder why. That's weird. That's good. Don't worry about it. It'll be close enough. Okay. Once you have the data entered, and I'm recording this, by the way, hit stat again, but then go to calc. And you're going to calculate the regression line. We're going to calculate an exponential regression line. So it's really simple. You select option 0. So let me go back so you guys know what I'm doing. First of all, are there any questions at all? Any question? Anyone's still behind?
What are we doing after we type in the numbers?
You have it typed in?
Yeah.
Okay, I'm explaining now.
Okay.
Yes. Dude, I already did it. You missed it. No, just kidding. All right. No, hit stat. Hit calc. Go to option 0, exponential regression. Now, very important, make sure X list as L1, make sure Y list as L2. If it does not, you can select L1 by hitting the second button and hitting where L1 is, which I think is number 1. And then hit L2, second 2 is L2. Okay. Don't worry about frequency lists. I even don't know what that does. But I am going to store the equation. When it's a store reg equation, reg means regression equation. We're going to store as Y1 because I want to graph it afterwards too. I want to see how the graph looks. So I'm going to store as Y1. Do you guys know how to call up Y1, Y2, Y3, Y4? Okay, this is good because you guys need to know this for AP Calculus. That's very good. To store an equation. No, because you have to, we're not storing as a number, we're storing an equation. Hit alpha, trace. You see that window pop up? Alpha trace. You could choose where to put it. I'll put in Y1. Okay, Y1 works for me. Calculate it. It'll give me the equation. That's my equation. So that equation is going to fit the data. We're going to plot the data and plot the equation in just a moment. So I have 0.475. So the scatter plot, I mean, we'll pull up the plot in a little bit. It's going to kind of look like this. Kind of doing a messy plot there. My equation is y equals 0.475 parentheses 1.358. Usually 3 decimal places is smart. Excuse me. Okay. And then it says to actually fit it in terms of E. I'll do that in a moment. Let's actually plot this first, and I'll show you how we can change the equation so E is involved. Right now, my base is not E. My base is 1.358. Fine, so be it. And this is growth, right? Because the stock price is growing, clearly. Just look at the data. Now, how do you plot this? Okay. You're going to hit Y equals, and you should see the equation there. It's right done it's done to many decimal places, so it's nice. What was that? You cleared it?
I just cleared it.
You can go back and do it again. Stat, calc, exponential reg, and then
I don't change the equation that it outputs in it's going to be ax squared plus.
go option 0.
Dublin R.
Okay. Now, when we plot this, we also need to plot the data points. So to plot the data points, go to plot 1. You see where it says plot 1? And let's turn it on. Hit enter, turn it on. But the problem is that I also need to tell plot 1 what to do, right? So plot 1's turned on. So for those who ever get errors in their calculator, like, oh, Mr. I'm trying to graph something, there's an error. That's correct because you have plot 1 turned on, and it's trying to plot a scatter plot. And then the window might be off and can't show those data points. That's why you get an error sometimes you try graphing, because you have plot 1 turned on. So if you hit the up key and hit enter, you can toggle it back and forth. Now, to define the plot 1, hit second y equals. You could define it. Obviously, it's turned on right now. Let's hit enter, and we could choose how we want plot 1 to look.
Enter on 1.
Correct. I want X to be L1. I want Y to be L2. Okay. And it's turned on. And notice there's several ways of plotting. You can do a histogram, you can do a box plot.
Box and whisker plot.
Ooh, look at you. Yeah. How do you know about that?
Good talk now.
Good. Do you know what it does?
What?
Do you know what it does? The box whisker plot?
It's just like
It looks at the median and the quartiles.
Yeah.
Anyway,
But you just knew that?
Yeah,
I'm not
box
gonna
and
do that
whisker
yet.
plot, bro.
You want that?
Yeah.
plot, scatter plot?
Which one are we doing?
What you doing?
You want the upper left.
I don't even know.
It should be.
It's all in one.
Weird.
Oh, yeah.
Subtle
It's
difference.
weird. Okay. You could change the markings to squares or plus signs, up to you. But make sure L1 is X list and make sure Y list is L2. Very important. Okay, if I hit graph,
You can choose the color.
the graph's not going to be totally accurate. The reason why my graph sucks right now because
Green.
think about it. I'm dealing with like time. Is time negative? X is time. And I'm dealing with stock price. Is stock price negative? Just losing money is you go out of business, right? You're down to 0.
No, that's what it does.
So we need to change the window. So go to window. Now, we started what year? 1, right? So let's put 0 and let's put 20 for X max. The stock price, I'll put 0 and it goes up to $54. I'll go $60. Okay. I'll make the scale 10. It's up to you how you want to do the scale. Actually, I'll do the scale as 5. It's probably a little better. Oh, why did I do the back key? Hold on. That means that every tick mark will be 5 units.
Okay.
So it'll be 12 tick marks from when you go.
So you can actually see them.
Yeah, so you can see what's going on. Okay. So that's a little better, right? And see the regression line. Sorry, the regression curve. That curve looks pretty accurate. It's fitting data really nicely. So there's a very strong correlation with time and with stock price when you think of it as an exponential model. The exponential model is a really good fit here. So linear wouldn't make sense, right? Because if I did linear, it wouldn't be going through the data points as well. So that's regression. So we're using a model to predict the stock price. So people can actually use this. So let's say now, the year 2025. Okay. So I'm kind of curious. So after 1986, 2025 is 39 years afterwards, right? Or it's 22 years after 2003. So just out of curiosity, let's take a look at it. Y equals 0.475. Let's look at the stock price right now. I'm kind of curious, actually.
Is this like actually accurate? Like,
I don't know. Let's find out. Let's raise it to the 39th power. So what you can do, if you go back to the home screen, if you hit alpha trace and select Y1, you can actually plug in 39 as like a function. You can treat this as f of x notation. And this is huge for AP Calculus. Because when you do free response problems, I know AP Calculus is a year from now when you do the AP exam, but you're gonna have to store equations on free response and use that for like 3 or 4 parts of a problem. You don't want to keep typing that equation over and over again. You need to save time. You only get 15 minutes per question on free response. So if you know to save it and know how to work it, like, oh, I need to plug a number into the equation, I need to graph the equation, just easy to have it already stored. I'm pretty sure Harley Davidson's not worth that much money. Let's look at it. Really, it's not worth that much money.
67.
But did it split over the years?
I don't know how to see if it did.
Harley Davidson stock quotes. I like Yahoo. Here
Doing it?
we go.
But I don't know where it should be.
Hog. I like that. That's a good name.
Yeah.
That's a cool. That's a pretty sweet name. Let's look here. All. Let's see. Yeah, I don't see any stock splits. And this is all adjusted. Yeah, so yeah, I guess I don't know.
Decade for motorcycle.
And by the way, what happened in the fall of 2008? The housing crisis, right? There's a crash. If you ever watch a Big Short, great movie. But it kind of explains what the heck happened. What happened over here around March of 2020? COVID. Stock market crashed again. Around here, who was president? Barack Obama. Things recovered. Who was president after that? Okay, I won't get political. Stop. Okay, we'll stop talking about politics. Anyway, but yeah, obviously it's not very accurate because the stock can't keep doing that. So, anyhow, all right. One last thing I want to do before we move on to the other parts of the lesson here today. I already graphed the curve on a scatter plot. Don't worry about the price at the end of 2004. That's okay. But let's look at part C really fast. Okay, this part's gonna be a little tricky. So bear with me here. We want to change the equation to have E as a base. Okay, I want my base to be E. So here's what we're gonna do. I'm going to give me a sec here. I need to think this one through. If I do natural log. Remember, how did I do this before? Actually, I think we do this. E to the X. Yeah, okay, this is what you do, guys. You take your base, 1.358, set it equal to E to the K. How do I solve for K here?
Natural.
Yeah, it'd be the natural log of 1.358. Does that make sense? Because in order to isolate this, I have to do log base E of this number, which is the ln. Okay, let me get my calculator here. You should get 0.306.
Well, y of 0 isn't 0.475.
Yeah,
So that means that k does e to the k.
we'll just go with it.
What?
This is based upon the model that with the data. So even though my first value is not 0.475, we still go with it.
But how? I don't understand how it still works.
That's because, well, first of all, that's not a k equals 0. That's a k. That's not x equals 0. It's x equals 1. right?
Okay.
So apparently that's just how the model works. So it's not going to be perfect, right? So even though your true starting point might be here,
Mhm.
depending on how the data looks,
Oh,
it might.
It's not gonna be perfect.
No, it's not going to be perfect. No,
It's fitting the data. It's not going
exactly. It's not going through the points exactly.
Oh, duh.
Yeah.
Yeah.
Yeah, you're overthinking it.
Okay.
Okay.
But it's gonna be a different like equation.
So anyway, if I do this in terms of E, it's going to look like this. Y equals 0.475. Still keep the same initial value. But now you're going to make it E raised to the 0.306 T. So some models will use E as a base. Not sure why that is. That just seems to be a standard. But sometimes when you do exponential regression, E might be the base. So if you want to convert from ABX to Y equals Y sub 0 E KT, you could just set E to the K equal to the base and solve for K. And that's how you do it. So it's still giving me the same thing. If I were to plot that right now, so if I go back to my calculator and did this, 0.475 seconds ln 0.306 x. And you see that it's just going to be pretty much an overlap. If I try tracing, yeah, it's still the same thing. So
we just use the original like A as Y0.
correct, right,
And
correct.
Why is it called Y0 then?
Y sub 0 initial Y value,
But that's not.
but based upon the model.
Oh.
That's all.
Sorry. Okay.
All right. This says interpret the value of K. Let's just skip that. The units will be years to -1 power, but let's just not worry about it. Let's look at another one. This case, we're going to use Desmos. I think Desmos will be a little better for us. And I think you'll appreciate that more. And actually, I think it's pretty good for you guys to see this, to know how to do regression in Desmos, especially for those who are taking the SAT. Okay, do you guys know how to plot points in Desmos? How do you do it? Right the point. Good. Okay. So I'll do 760, comma 0.
40, 0.184.
740, comma 0.184. Now, what I'm going to do before I get too carried away, let me plot these. Let me zoom out. Okay, so far I have that. Not probably the best. I might need to adjust my scale. So adjust my scale, I could probably go from 0 to 800, let's say. Make the step's fine. The Y would be from 0 to like, say 1. Yeah, it's a little better. Okay. Now, before I plot the rest of the points, to make a table, if you hit the settings button, hit table, it makes a table for you right there. So what you can do is you can keep typing in the rest of the data points this way. So 725, 700, it's gonna be so much easier this way. 650, 630.
585.
Dude, thank you. 580, what's the next one? 580? 550, great. And then 0.328,
0.565,
0.565.
1.079,
Keep going.
1.291,
Mm-hmm.
1.634,
Mm-hmm.
1.862,
Mm-hmm.
2.235.
2.235. Okay. So I need to zoom out a tad. Okay. So now I want to fit this to a log regression. So you see that little scatter with the line on the top left corner? It's kind of hard to see right below the plus sign. This will add a regression line, but I don't want to do a line. Actually, I want to do log. So I'm going to do a logarithmic regression. I know it didn't change very much, but notice it gave me a log equation there, right? I don't know what log mode means, but what does log mode mean? I have no idea. I don't know. I'm not worried about it. But yeah, so this will give me the log equation. So I create a scatter plot. Check. I found the log function, which is y equals, what is it again? 45.786. Plus natural log. Oh, minus, sorry, 6.903. Times ln x, yeah. Okay. That's a minus, my apologies. So yeah, there's your logarithm equation. And it's actually a pretty good fit. R squared is a metric used to measure how strong the correlation is. It's called the correlation coefficient or variance, but don't have to worry about that. But once you have that, and I already graphed it, so we're good there. Use it to predict the pressure at 560. So x is, sorry, the height at 560. So 45.786 minus 6.903 times natural log of 560. And actually, we could do when you're in Desmos, you can actually type in x equals 560 and find a point of intersection. What's the height?
2.1.
There you go. Desmos is much nicer. Now, why is this important for the SAT? I've seen some SAT questions. I actually do a lot of like test prep on the side. And they'll give you, I saw one question on the Blue Book app where they give you a table of a bunch of data points that are on a quadratic function, and you have to find the equation that fits it. So you could like plug in the y equals ax squared plus bx plus c and solve for a, b, and c using a system of equations and spend minutes doing it. Do it like that. Punch in the Desmos, gives you the answer right away. Okay, just saved you guys hundreds of dollars in test prep. You're welcome. Okay. But yeah, that just saves you so much time. So you could use this for the SAT. If you have to do a quadratic model or linear model, this will help. You can punch data points in and get the equations. All right. Questions on that one? All right. Okay, last one, logistic regression, which is actually probably a more accurate model because things have to reach a certain limit after some time has passed. So let's go ahead and punch this into Desmos again. So this is looking at population versus time. Oh, sorry, yeast biomass, whatever that is. Okay, fine. So let's do this right now. So I'm going to update this. And I think I'm just gonna close that. That'll be easier. So what's our first data point?
Like you can turn a table from the start.
You can just
So
Yeah, but I need to type over the data anyway. Were you saying overwrite the data or?
no,
just like
put
start
in a
with an
from the
empty
start.
table.
Oh, how do I do that?
You just type table.
Or just click plus.
Dude, look, I'm learning so much stuff. Awesome. Thank you, man.
Welcome.
All right. Wow. I'm so excited. This is great. Just type in table.
You can do it with anything in Desmos. You just
Or,
type it.
or if you go on the top left, so like plus.
Got it. Got it. You can add table. Got it. Yeah. I'll do that next time too. Thanks. Wow. I'm learning so much today. Yeah. So you can see this is really helpful. All right. Now, next up, I'm going to do, 9.6. And seriously, in real life, you wind up getting a data file and you don't have to type this in. You have to clean the data perhaps, but, and then you can use like R, Python, or any language you want to use, but always good to check the integrity of the data, see if it makes sense. 257.3.
350.7, 441, 513.3. You're still checking.
This is show 0.0. Doesn't matter. Okay. 573.3.
513.3.
Oh, 513.3. Keep going.
559.7,
Mhm.
594.8, 629.4, 640.8, 651.1, 655.9, 659.6, 661.8.
So I might need to adjust my table again because it's kind of out of whack. So probably go from 0 to like say 700. And probably go from like 0 to 20 for X. Okay, cool. Oh. Yeah, see, logistics gonna look pretty good. So when I fit my data, if I select this again, go down to logistic, and there we go. There's my logistic function.
We're just gonna do logistic.
Boy, this is just the logistic. There's a logarithm.
And it's a little funny because they write like this. So I'm not really sure what to think. I'll just go with what I see right now. It's not really the way I want it written, but it's okay. So I want an A value, but it's not giving me an A value next to E. But it's okay. 0.547 X minus 4.271. And it fits really nicely. So yeah, so that's regression. And what's the maximum capacity? About 663 looks like. I definitely graphed it, definitely created a scatter plot. And the user predict at 19 hours. So I could go back to the graph. If I plug in X equals 19, it's about 661.57. You click the top left corner, and then it gives you, if you start off a linear regression, you go to the pull down menu, and you can change any regression value. So yeah, it's pretty nice, pretty lovely, right? It's really nice. So 661.571.
We just lost the bear.
Okay, all's good. All right, there's no homework though. So I'm not sending any homework on this. Because I didn't send homework in the other class. But yeah, just we'll talk about it one more time tomorrow. There'll be a quiz on this on Thursday. Okay. So yeah, but we're gonna start calculus tomorrow. So I'm done. You guys just relax.
Unclear. Why I want to.